Niemegeers. I'm associated with TU Eindhoven as a guest professor in the Center for Wireless Technology. There are a couple of things that I would like to say before we start. During the seminar, please switch off your microphone, switch off your webcam, and if you have questions that you'd like to ask the speakers, put them in the chat. And further, the webinar is being recorded and will be available later on the YouTube channel of KIVI. Okay. Connectivity on the North Sea is a very interesting topic because the North Sea is a place where there's a lot of intense economic activity that is growing and becoming more and more complex because many partners are involved, private partners, but also governments, etc. So it's very complicated, and one of the speakers will highlight that. So we have two speakers, Fred Hage. I will have every speaker introduce more detailed when we start the talk. Fred Hage, Rijkswaterstaat, who will expose the problem and talk about how Rijkswaterstaat, Dutch Rijkswaterstaat is approaching this and the pilot projects and things they are doing. And then Relja Djapic of TNO-ICT, who will look at how a particular technology, namely 5G, could help in solving the problems we have there. Okay, so I will start. Let's start with the first talk by Fred Hage. And let me briefly introduce Fred Hage. Fred Hage is started out as a biologist and ecologist, and his talk is called An Ecosystem, but it's a different kind of eco, I think. And he started as a biologist, ecologist at Wageningen University, has worked for the Dutch Institute of Ecology, a KNAW Institute, but he has been attracted to everything ICT, and in particular networks and data communication. So he has played several roles in that context. And in 2017, he did a research assignment on broadband in the North Sea for the Coast Guard. And so he has been more and more associated with maritime ICT. And so in 2020, he started to work for Rijkswaterstaat on exactly that problem. So I would like to give the floor now to Fred. So I will stop sharing and I'll let Fred take over the screen. Here we go.
Yes, hello everybody. I hope you can see my screen now, by now.
Yes, we can.
It's always a few seconds later.
Yeah.
I can skip the first slide because it's in Dutch, but I've prepared my presentation in English, all slides, so happy to do it try it in English as a Dutchman. On the first slide, you see the logo of the CFNS. It's the Connectivity Field Lab North Sea. We started in 2020 within Rijkswaterstaat. And this introductory slide shows you how the market is predicting the connectivity on the North Sea. This is a picture you can find on the website of Tampnet. And as you can see, most of the North Sea, of our Dutch part of the North Sea, is covered by 4G. So that's what we. So why bother doing something if you have 4G on the whole North Sea?
Yeah. But Fred, could you please, Fred, I have a remark. Could you please use presentation mode so that we get the full size of the screen?
That's what I'm doing. So
okay.
It's not with me. It must be in your Teams.
Okay.
It's a full screen. It's a full screen.
Okay, you did. Okay.
So yeah. So what I did is well, if you go to if you actually see what's happening on land and on sea, you're misled also. And of course, this talk will not only be about 4 and 5G. but on connectivity in a much broader sense. But of course, we have an innovation lab started, and 5G is a promise for communication. And also on this slide, you see all the active 5G antennas, and in the Netherlands. And of course, there are 3 times 4,000 on land, and some are projected on the sea. You can also see that KPN, the green one, is the only with a base station in the middle of the Afsluitdijk. The other ones are missing there, and also this picture is not still correct. This green one is actually 1.5G of KPN, but from Odido only these 2 are active. And if you click on these ones on the interactive map of antennacard.nl, you can see that there are projected, and but in fact they will never be there, because only the first 3 of these will be there. And if we look what's happening now on 4G, you see a lot more dots on the sea. The purple ones are from Tampnet, and the blue ones are Odido, and the green ones are from KPN. And Vodafone doesn't have only mass on the North Sea. So that's what is the reality. And of course, there's a lot of interest in digital infrastructures now. The state of the digital infrastructure, the backbone of our digital economy, was published in January this year. And this is the outline, but of my talk. I won't be able to cover all the subjects in depth, but when we distribute this presentation, you have a nice introduction of what's happening. So the first connectivity type I want to show to you, this is an actual heat map from the Things Network Mapper. And you can see that the LoRa one, I hope you all know this technology. It's in the 868 megahertz as far as I know, and it has a very low bandwidth. Theoretically, I think it's about 50 kilobits per second. In reality, you get 20, 30 kilobits per second bandwidth with this kind of technology. So it's an IoT, and you can also see that there's a nice gateway, as they are called. They're not called access points, but gateways. The LoRaWAN gateway is on the Stena line, so you can see that in the middle of its track, it's getting good connectivity. And well, so this is one of the IoT connectivities that's a bit on sea. You can see on several oil and gas platforms. It's also used for this network. And of course, there are a lot of active on land. And if you look further far, where are the clients that have connectivity with what's gateway? You can, sorry. We can also look what's happening here, and then you see that there are sometimes connections are made very hundreds of kilometers or miles away, but most of them here you have 2 gateways on wind parks in the North Sea, and they are making connections, so that's nice. But how you can use it for IoT. There are also life-saving devices using LoRaWANs. If I would trust that, I would know. I wouldn't know. So another maritime connectivity technology is VHF data exchange, or AIS. AIS is developed to avoid collisions between ships. But they can communicate only with each other, but also with land. And a new kid in town here is VEDES. It's developed with internationally. by the IMO and by the IALA. It's the Lighthouse Association, the International Lighthouse Association. And it's theoretically it is 8 times more bandwidth, the VDE, SAT and TER, the VDES, than the original AIS, as you can see, but it's still 307 kilobits max theoretically, and in practice it's about 100 kilobits what you can get with this kind of. And not many people know about VDES, and that's because there are only test satellites in space at the moment. So it will take several years. And what in the Netherlands from the 1st of January, some channels, it's a channelized communication. Some channels were made free for this VDES, and you can see that in this scheme. And so you have ship-to-ship communication, ship-to-shore communication, and now with VDES there will also be satellite communication in 2 forms. Satellite long range only read only, so to say, only the position and the destination and the ETA, the expected time of arrival, and that kind of information can be sent. And there are several programs on the web and on your phone, Ship Finder and Marine Traffic, who pick up the signals, and you can see all ships that are using AES, what's the current position or near real-time position, and what kind of what is the ETA. But and ships with more than 300 registered tons are obliged to use it, but not everyone and not every ship is using it. Sorry. So that's another kind of communication that's available and will be available. You can, and then this brings us to the satellites, I think. The satellites were, of course, the only broadband until now on sea, and that were traditionally this was geo satellites. There was 36 kilometers in space from the equator, and they are called geostationary because they're moving with the turning of the Earth. So they have a fixed position from Earth. This table, of course, you can look up in Wikipedia what's GEO and MEO and LEO satellites. But the GEO satellites are they have a satellite design life, a replacement cycle of 15 years, and I think that's one of the biggest problems. I mean, what's now in the air was developed 25 years ago and put in the air 10 years ago, and they last for 15 years, but if they last 25 years, they're still working. So they are just using IP now as a protocol, the current generation. It's the first IP generation in the air. Then we have the middle Earth orbit satellites, around 8 kilometers from the surface. Then you need some more satellites, because for geo satellites with 3 satellites you can cover the whole Earth, as you can see in the beam forming here. There are the costs are somewhat low, but not much, or some high, but and they last for 12 years. And there are only a few constellations of MEO, but they're still coming. And of course, then we have the LEO satellites. They are most prominent in the news now. We have, of course, of Starlink and OneWeb, and Project Kuiper is coming, and more are coming. They are relatively low orbiting, but you need hundreds of thousands of satellites, and it's very expensive to have such a constellation, to operate such a constellation. But they only last for 5 to 7 years. So the technology is replaced very much earlier than the other ones. And also, when I did my study for the Coast Guard, Google and Facebook both had hubs, high altitude platforms, and there, as you can see here in the right corner, they are in the stratosphere, so they're just above the airplanes that goes, and of course they have a low latency, and I think what's very special about this is that all the other satellites until now need a receiver, and when it's on a ship, they need a BDU, that's a below deck unit. So you have a disk or flat panel to receive the signal, but you can't have it directly on your smartphone, and that's different with the hubs. And nowadays the balloons from Google are stopped. Also Facebook has stopped, but for instance, Airbus is still developing and testing at the moment. I saw it in Australia. They have testing these hubs, and so what they are doing, they will bring us 5G direct to device, D2D. And here again, you see a nice picture of how high they fly and what's the latency, the expected latency. Well, in my experience, 600 milliseconds for a geostationary satellite is that would be terrific. Mostly it's more than a second, the latency, so it won't cover all use cases. What you can do is have a telephone voice call with it, because technology will hide the latency for you, and if it's a stable connection, as you know, it's not the latency that's the biggest problem. So, and here you see the Safe that's the one from I took this picture of. It's from Airbus, about 20 kilometers above the surface, very low latency, and according to this marketing picture, it's the cheapest way to get 5G on big surfaces and a rural environment. So we'll see whether this will be the new 5G 4C. And I think that Relja, the next speaker, will go into the combination of 5G and satellites. So I leave the satellites for now, and I'm turning to the energy on the North Sea, because on the left side you see the current installed energy production in the North Sea, and I zoomed out to the bigger North Sea. Only this small piece is the Dutch part of the North Sea, the what's called the exclusive economic zone. But you see that there's between England and Norway and around the north, there's a lot of oil and gas exploitation, and so this and the green fields, you see that are the current wind parks that are active. So that's in relatively the oil and gas, the fossil energy sector is still dominant when it's about the economical use of the North Sea. And on the right picture, I zoomed into the more to the Netherlands part. As you can see here, that Belgium only has a very small piece of North Sea they can use exclusively. Germany is also smaller than the Netherlands, because that's how it works. And what is depicted here is that these big energy industry players, they are planning energy hubs where electricity, but also molecules in the form of hydrogen, will be exchanged within the hub, but also between countries to stabilize the grid internationally. And the red ones are the ones that are foreseen now by the Netherlands, but it's only in the planning. Well, as you can see, these energy hubs will connect different countries on the North Sea. And the first picture also, you see all these all these pipelines bringing and cables bringing the oil and gas to the land. And what we are trying to do, that was my, what also will be happening now on the North Sea, and that's especially in the Dutch part, is storage of hydrogen. And this is just this won't say what will happen actually, but this is what is in the inventory where we can store hydrogen in the seabed. Is depicted in this picture, and you see that here the Netherlands, our part of the North Sea, will play an important role, and in a lesser degree, it's also for carbon capture. The blue, the carbon capture that is planned on the North Sea, and the field. What we are doing in our connectivity field lab North Sea is trying to convince the big players, the big economy players, the old and the new kids in town, so to say, if you are planning energy infrastructure, please help us make this puzzle. So on the bottom, you see the molecules and the electrons, they're trying to store and to distribute and build infrastructure and hubs for it. And what we are saying, okay, if you do that and you're making a lot of money there, and you please help us to also build digital infrastructure on the North Sea, and so that we can use that we can have antennas and masts for radio waves, but also have backhauls with fiber. So that's what that's where we're up to. And then I zoom in to the Dutch part, and this is from a study from the Hague Center of Statistical Studies. It came out in November 2021, and of course, as you know, less than a year later, the Nord Stream was detonated, and that was a shock. But they already warned us about okay, this is today's economic value creation in the North Sea, and a lot is happening there, as you can see. But if we look at all the plans, and we are trying to imagine what's happening in 2050, the North Sea will be really, really full. And I can't go into all the details, but the orange are the wind farms that are planned, or where we are looking for wind farms. Maybe they won't be filled. You also see these are the ship highways, so to say. Nowadays they go to Scandinavia and to Germany, to Scandinavia, but you also see there's a new route planned because the Arctic ice is melting, and there will be a new shipway to the above the Americas. So the North Sea is already the most trafficked sea in the world, and it will be worse. That's the story, and. So the North Sea is becoming full, as Ignas also said in his introduction. And in 2021, it was Stratix, the consultancy, telecom consultancy and ICT consultancy firm. They made for Rijkswaterstaat. They did a study. They made an independent position paper. I won't read them all, but. You can download it on their website, and I took some very interesting conclusions they made. So the first one is the same we already said. it's an urgent need for frequency policy, we think, because there's an increasing demand for connectivity. The situation on land is completely different as on the sea. So, but on this moment, the spectrum is divided and and the policy is purely based on the situation on land, and this leads to the conclusion that the Ministry of Economic Affairs should set up an integral review of the North Sea frequency policy in cooperation with our ministry and the Rijkswaterstaat, and that's what they have advised. And of course, and frequencies, but I won't have to tell you that, are the oxygen for the connectivity also on the North Sea. And an obvious solution would be to have a frequency policy working group formed, user-based, and not only advised by the current network operators that operate on land. And once again, of course, we have an opportunity here to lead the way in innovative solutions. Well, this was in 2021 and early 2022. It didn't work out that good, so to say, and that's why we last year strict also on request of Rijkswaterstaat did a research study. Okay, well, how can we get 5G broadband around the wind farms? And they came with some interesting conclusions. Well, what we are working on, of course, where the new wind parks are coming through 2030, already a large part could be covered with broadband connectivity. And in this study, satellite communication was excluded, so they're talking about 5G here in practice. And Rijkswaterstaat, we have the MIVSP. They are setting up and maintaining the technical rooms and the masts on the TENET platforms in the wind farms on sea on behalf of the Ministry of Economic Affairs. So it looks logical to give them also a role in setting up digital infrastructure for connectivity on the North Sea, and not only for the sensors and they are placing and now. And also the coverage of Tampnet is dependent on the oil and gas platforms, and these will be commissioned. So there will be a need for new antenna sites and sensor sites, and that could be on these wind farms partly. And also, and I'm very happy with that one, because now also a firm like Strict has concluded that the neutral host services and shared RAN would be a good solution to give multiple operators to offer the services, and then we have a choice and not only one provider and no choice. That could make a market, so to say. And here again, they say that our field lab could play a role there. Well, I'm happy with this conclusion, but so that in the meanwhile, between these, we set up in the field lab a program, an innovation program, and we started with multi-connectivity. We said if new connectivity are coming, you won't be able to use only one. So maybe you need some kind of modem or router that has multiple kinds of connectivity technologies that supports it. Well, we very much like to go to try these LEO satellites, the Starlinks and the OneWebs. We also started a pilot, and I can't go through all of them. You can look at them later. But what we did is end of 2022, we said, okay, we need 2 pilots to demonstrate what's possible with technologies that are coming. The first one was this LTE 450. That is the 450 megahertz currently used for smart meters on land, but planned to be phased out up to 2035, and there are not many, and replaced by modern 4G and 5G and 6G compatible technology. And this, as there are no smart meters on the sea, we could use this frequency, the spectrum, to have, and there is an ecosystem developing of devices and of routers and of all kinds, also mission critical devices are being developed for this kind of technology now. We could sort of try that at sea, so that we start the pilot there, and the other one is okay. In theory, the land operators could cover the territorial zone, the territorial waters, 12 nautical miles zone from land with the 700 megahertz 5G spectrum, but they have no obligation to. So it's hardly covered from land, and we are trying to map this so that we can have and also the RDI, the former Agentschap Telecom, they don't measure on land because there is no obligation for the MNO's to have a coverage or deploy their services there. Well, you can see we're also active in. We also were interested in our team we called Maritime Edge, that all kind of not only combine all kind of technologies in the endpoints, but also to make this this digital infrastructure at sea not only a data pipe to land to data centers, but make it an edge computing and have all kind of digital infrastructure use the same physical infrastructure. And one of this is the internet, the international internet cables. So we said, why don't you bring the landing from land into the sea, and then you can share that one also, and not every new cable has to land on land. And well, we are in, and of course we were involved with pilots. We tried to get involved, I must say, with dynamic spectrum sparing and management. And end of last year, the portfolio was looking like this, because we really started with the pilot. We also tried to start with coverage of the territorial waters. And okay, I must speed up now, I think. And we try to integrate it. So what we did is
not really. You can take your time.
Okay. Thank you. So what we did is we have a measuring setup and equipment for the 5G in this pilot that is running now, and it's on a ship now. But this the devices, we're also able to connect satellite to it and have a multiple one, and try this integration between 5G and SATCOM in the pilot that's running here at the moment. But of course, we need funding and we need permission and all kind of stuff. But it's how we're setting up, and we're doing the same with now with in January we get granted a pilot together with TNO, not Relja, a colleague of him, for trying studying the possibilities of open run. And of course, what we want to develop is a maritime open run. that only uses a few frequencies to have 5G on the sea. And well, and of course, that's in a way, that's the same as a maritime edge cloud platform. Partly, we are still looking at the stakeholder, who are the stakeholders, and how can we manage to get this? Because in the end, 5G will only run with AI and on the edge, and so you need more than only a mast and a radio, so to say. So that's how we are now trying to combine these and make building blocks to have this program growing and running. And the other one, what happened is in the former, you could see that we called it internationalization. And we thought about becoming a TIP community lab. I won't go into that now. It's from it's an initiative started by Vodafone and Facebook to have the open run. And what we do now is we say, okay, we are trying to make an international ecosystem. And well, that was one of the biggest changes we didn't see coming when we started last year in January 2023. But in March, we came across the Digital Ecosystem Institute, who was already doing other field studies with and innovation development with Rijkswaterstaat. And so they started helping us setting up and making the field lab into a digital ecosystem. And of course, now we say, okay, you've seen the map I showed you. You can't do it alone, but you also can't do it as the Netherlands only. You need your neighbors. The North Sea, it's an international waters, and especially if you're going to use wireless technology, you should work together with the other North Sea countries, also the UK, although they're not in the EU anymore. So, and we think that building an international ecosystem and is the way to go to have this kind of to have, well, finally the mission of our field lab is to provide connectivity in the whole Dutch North Sea by 2030. So to reach this goal, to fulfill our mission, we think we should cooperate, and that's the only way forward for us. And I can't go into all the pilots. I think here you see that we had some some trouble starting up this coverage study for the coast for the 12-mile zone of 4 and 5G, but data is coming now. I think a lot nicer heat maps will be produced by our current student who is working on this. He's a mathematician, and he is going to he's going to train models for us. And but the first data I depicted here, as you can see, there's a lot of variation in the quality of the signal by this standard output, so to say, the standard dashboard output. And I just show you the same trip. The devices, the measuring device we have on board has 4 modems, so we can simultaneously measure the connection quality with four networks at the same time. And I show here you this what's on the SIM card from Vodafone and the SIM card from Tampnet. And of course, Tampnet should not be within the 12-mile zone. That's about around here, I think, 12 miles. But as you can see, sometimes there are good connections made with Tampnet also. And that will be, well, that will be also be difficult to shed out because they've got spectrum that should be used only outside the 12-mile zone. So this is on our way, and one thing our students will face, and everyone face, and also the policymakers face, is that we don't have a standard grid. There is a standard grid for the North Sea. It's developed in 1984, as you can see, by the oil and gas industry. And at that time, it started with a few, but also oil and gas stations on the North Sea. We did a survey in 2021 about connectivity. What connectivity can you, mainly based on jurisdiction, because in the territorial waters the same law as on land and the same rights apply, but we also have the wide inland waters who are not the MNOs on land don't have an obligation to cover wide inland waters. So we take it in our survey, we take it with us, and also in our solutions we also want to be able to deploy them on the wide inland waters, like especially here in Zeeland. Well, offshore installations, traffic separation systems. That's the ship highway I showed you in the other zones. And of course, we have the port approach areas, and there are also the ports. There by IJmuiden for Amsterdam, there by Rotterdam, there are Antwerpen en Vlissingen, en there are aan de Eemshaven.
Fred, mag ik je even onderbreken?
Ja.
Ik word nu voor de derde keer eruit gegooid. Ik heb me keurig aangemeld via Eventbrite, €10 betaald. En ik weet niet waarom ik er steeds uit word gegooid, maar ik hoop dat ik nu mag blijven van degene die me er steeds uitgooit.
Ik gooi niemand eruit in ieder geval. Ik presenteer alleen maar. Dus
Oké, ga rustig.
Ik hoop dat degene die
de camera uitzetten.
Ja. Ik zal even verder gaan, ja. Nou, en de derde is, die ik even laat zien, is we hebben een groeifondsaanvraag gedaan. Daar heeft de hele ploeg aan gezeten. Die hebben ook schetsen gemaakt. En ja, dan... maar er is dus ook het CBS heeft gebruikt, met name voor alle economische activiteiten en voorspellingen, maar ook voor het gebruikt allerlei prachtige grids, maar die zijn helemaal gebaseerd op een aantal huishoudens, een aantal gebouwen. En ook het grid zelf loopt fysiek niet verder door dan een klein stukje buiten de kust. En dat is best wel een probleem natuurlijk als je aansluiting zoekt.
I think, sorry that I interrupt, you have switched to...
Sorry, yes, yes, that was because of this interruption. Sorry, so I repeat, my excuses. There's no grid, standard grid for the Dutch government to use on the North Sea. The oil and gas industry made in the 80s made their own grid, so they could communicate and they could do their work. And there are several approaches thinkable, and our student who is going to use this data that is coming from the sea, we are measuring, but of course, this ship will also be outside the territorial waters, and we'll try to expand our measurements on the North Sea about current 4 and 5G coverage from land, also beyond the 12-mile zone. And what I was showing is that there is no standard grid, and in last year an initiative, the Digital North Sea Initiative, also made a nice grid based on what they expect there to be in 2030 and beyond. But well, that's one of the this is one of the problems we face when we try to look what's happening on the sea and compare it to what's happening on land. When it's about And this slide I produced, it's very recent. Of course, we knew this, but it shows you that in this 450 megahertz range, we are doing this pilot with Utility to Connect now. In the industry, this is from Ericsson, a blog from Ericsson it can be used for, well, you can call it broadband or not, but at sea, 30 megabits per second is still considered broadband. So with this new technology going from LTE, that is 4G, to new radio 5G, also the 450 megahertz can be used for public safety and defense, for utilities, and of course one of the other within our Ministry of Infrastructure and Water Management, the ProRail is also part of that, but they have their own. They make their GSMR. That's a 2G technology. It will be upgraded to 5G the coming decade, and also they also use this below 1 gigahertz spectrum for long range coverage, because that's of course where it's low band, but it's also, and thereby it's long range. It can be used for mission critical private networks, for mission critical networks, and it's in interest, and big interest in the EU now. I can't show you the next slide, and that's why we go to 22, because I just got it today, and the EU is now going to initiate a study how they can harmonize the 400 megahertz band, including this 450 we are using, to give priority to utilities. But it's only a study, so in the Netherlands it's probably too late, because it's being divided. It is being given away now this year, or not given away. It will be auctioned. There's one license available, and it will be auctioned later this year. Well, this brings me to the ecosystem journey we started in March, and in September, after the summer holidays, we had our first roundtable workshop. More than 20 organizations were there, government, and market, and university were there, and the second one was on November the 23rd, sorry, and this is of course because we already had some kind of running field lab. We also said, okay, let's do a showcase. Meanwhile, how an ecosystem, a broader ecosystem, can work on a use case, and this use case is trying to fly a flying drone to open sea from Rotterdam, from the Rotterdam harbor area. So, and this one, the first meeting for this BVLOS, as it's called, Beyond Visual Line of Sight challenge, as it's for this community in Rotterdam, we did on November the 15th. And I personally held a talk like this a week later on the iBestuur on Digital Infrastructure Congress. And there we got a lot of help and interest. And meanwhile, the no-go has come to a go. So we go in this year, we start in phase 2. And all I can tell you that is in the meanwhile, 2 weeks ago, less than 2 weeks ago, we were in Barcelona on the Mobile Congress, Mobile World Congress in Barcelona, and part of the Dutch pavilion there. The Dutch, it was a very helpful and very successful event also for us, because I did in Barcelona. The main teams were Open RAN, private 5G, and AI, I think. So, but for the first two subjects were very interesting to see the whole mobility world gathered there and got information. Actually, I got support from the English Innovation Center and initiative that's working on 5G, the Catapult. They said, okay, Fred, we will help you setting up this Open RAN 5G together with TNO. If we can help, let us know. So, and what's happening next is that
you should think of rounding up now. Yeah.
Well, this actually will be my this should be my last slide. So next week on Monday, another, okay. I think not only 20 but at least 12 to 15 organizations will start phase 2, and we'll look forward to build this to build our field lab to make it operational as a digital ecosystem. And what we will discuss are these kind of themes. So the unmanned flying and sailing, data sharing, living digital twin of the North Sea. Of course, security, both maritime as cybersecurity, will be a theme. We will try to make this advice from strict at 2021 to form a work group for the frequency policy, for the frequency plan for the North Sea. Maybe that will be too late for the 450, for the 700 and the 3.5, but there are other frequencies coming available perhaps, and we can advise specifically from a user perspective, maritime users perspective, the policymakers. And of course, there will be a lot of regulatory bottlenecks. Now, we'll try to, with all users of, that are gathered to make the optimal spatial planning. And we do have wind farm owners and that kind of organizations available then. And of course, the governance and other operational we should deliver innovation services to the rest of the Netherlands. That will be, and it is now not only DEI, but also ecosystem services, the same organization that organizes the Dutch representative in the World Mobile Congress, that will be helping out. And that's my last, is just to distribute in my presentation, so you can get more inspiration by following the links that are active and on this last slide. So that will conclude my my talk. I think I filled it up, didn't I?
Okay, thank you very much, Fred, for an interesting talk. Let's take a look at whether there are any questions in the chat. So there was a question of Rogier on where the LoRaWAN gateways and access points are positioned, but some people already in the chat also indicated something like on wind platforms of TenneT, but also the question, can they be mounted on buoys? Can you comment on where these things can be, the LoRaWAN? Can't hear you.
I have some limited experience to install them myself when it started in 2015, 14, I think, but in the Netherlands. But well, the gateways, I don't think they can be installed on
a buoy.
On buoys, but with enough battery, maybe, but well, on the platforms and on the oil and gas platforms and the wind farms, it wouldn't be any problem. You don't need that much of currents.
Okay. Then there were some remarks on the frequencies, but I think you went into that. A comment by Rogier, broadband is not strictly about data transmission, but rather the width of the frequency band used for the communication. So that's just a remark. I had a question, is is there a kind of a view of the quantitative view of the traffic to be expected, the traffic that needs to be carried by these networks? Like, for instance, will there be more and more video? Because in many applications, like for inspection and stuff like that, high quality video is important. Is there a picture of what this infrastructure would need to handle?
Well, that's also a kind of chicken egg problem, I think. We did this kind of investigations within the government users, so to say, and then well, because there's only that limited connectivity possibilities now at sea, you get answers from for instance, from the police. They say we will need at least 100 megabits a second, 47 and 5 nines after the semicolon, because that's the only way we can work. And other users say, well, we don't know because we don't use it now. But to give an example, if we think that to protect the wind farms also visually, and not only with radar and AIS, because radar has its limitations of detecting exactly what it is. It's just a beep what you see, or dot, and AIS can be turned off. So there also will be visual and infrared, but can inspection, and then of course you need bandwidth, and we also think that having these autonomous ships that will need a lot of bandwidth. But exactly, there are no measurements because it's chicken egg. As long as there is no infrastructure, and it's also what we hear from Belgium, for instance, where there's 5G available longer in harbors and also on wind farms. They have, as soon as and we see it also on land, of course, as soon as there's a new generation available, the data. The data, a lot more data is produced and used on it, so to say.
Okay.
Yeah.
Okay. Thank you very much. I think we need to move now to the second speaker. Fred, can you unshare your screen?
I already did.
Okay, you already did. You already did. Okay. Yeah. So the second speaker is Relja Djapic. So he's acquired his master's degree in electronics and telecommunications at the University of Novi Sad in Serbia. Got a PhD degree in signal processing in Delft University, and worked on phased array and ultra wideband systems, the signal processing for that. He joined TNO in 2006, where he worked on the development and rollout of broadband communication systems for national and European telecoms operators, participated in many projects around 4G, 5G, etc. And since 2017, he focuses on the integration of terrestrial and satellite networks and 5G. And he is a contributor to the 3GPP standardization in that domain. So, in the talk of Relja will touch on 5G, right? Go ahead, Relja.
Yes, indeed. Thank you, Ignas. Let me just share my screen. And now I should be in the presentation mode, so I hope you see the full presentation at the moment. Hello?
Yes, I see it.
Okay. So let me begin with the presentation. So tonight I'm going to talk a bit on 5G as a connectivity enabler over the North Sea as part of the ongoing webinar. So a bit on the content, very brief introduction of TNO, the department where I am currently working. Then I will introduce several use cases representative for the North Sea, and talk a bit on the service requirements. That was just the ongoing discussion at the end of Fred's presentation. I will introduce 5G features. Within the 5G standard, there is a vast amount of technological features, and I will introduce just several of them that are enablers for coastal or maritime coverage. I will talk a bit on integration of terrestrial and non-terrestrial networks, and subsequently the conclusions and possible way forward. So I'm working at TNO, Dutch Institute for Applied Scientific Research, within ICT unit, and I'm with the networks department. Within the networks department, we have excellence in all kind of telecommunications. It is terrestrial, wireline, wireless communications at all OSI layers. We have a strong expertise in radio access networks and system architecture. We are very active in 3GPP standardization, where we have a chairman of Service and System Requirements Group, SA1, and we are also contributing to run SA groups in parallel. On the right-hand side, what you can see is actually how we are organized within a networks department. We have our own 5G core network. The platform is called Hi5. It is in the middle in the blue circle. It is located in The Hague in our office. And we are using a 5G core network, that is the intelligence of a 5G network, to conduct different trials. We conduct the trials through various field labs, and you can see on the top right there is like rural trials in Groningen related to agricultural applications and use cases. So how you can use 5G network in that domain. Another one is Do IoT Field Lab, Unmanned Valley, close to Leiden in Valkenburg. There is a full implementation of a 5G core and radio network, so we can conduct trials on unmanned ground or aerial vehicles. We are participating in rail center trials related to rail use cases. And at the bottom left, you can see the smart road trial that is conducted in our location in Helmond. And to conduct all these trials, we have a core network of 5G, and we have various implementations of radio access network. Also, all run or open run configurations of radio access network. Examples of trials are, novel concepts for radio and core, and new applications such as augmented reality, virtual reality, smart factories, automotive services, and IoT. So this is the introduction on TNO, and I can now switch to the North Sea use cases. I can start with the Coast Guard use cases for search and rescue scenarios. And in these cases, it is very important to have low latency between the end users that are communicating with each other. And it is also important to have extremely high reliability of such connections. Illustrated on the figure are several boats of Coast Guard, and this reliable and low latency connectivity should be provisioned on each vessel, but also it should allow for connectivity between two vessels. For the time being, it is, for example, C2000 or Tetra systems for push-to-talk cases that are implemented to cover these kind of scenarios. In the second figure, we can see use cases related to shipping. In that use case, what is interesting, for example, it is to monitor the status of the cargo. For example, if there is an air-conditioned container, it is possible to monitor the status of the temperature or the content of the cargo anytime, anywhere. It can be real time, then it requires a continuous connectivity, but it can also be periodic, just reporting the status from time to time to the central location. In this kind of scenario that I just described, it is kind of IoT, low data rate and low periodicity of data exchange that are characteristic for this kind of communications. And in these cases, we can think about LoRa sensing that is reporting to the central location on the ship, and then via satellite it can be distributed to a central location. Oil or gas rigs is another use case where process-related data is exchanged and collected to monitor the process of exploitation of oil or gas on the sea. Fishing is also an interesting use case, so it requires connectivity, either voice, for example, mariphonie, it's a Dutch word, or marine communications is a voice communication that has a very long reach, and it is used for crew members to communicate with other ships or with the coastal units or traffic management systems. Wind parks, offshore stations. In this case, there are different kind of requirements or services to be provisioned. What very often is mentioned is the use case for monitoring of the status or asset monitoring, so the status of the wind turbine blades or the mast of a wind turbine. And in that cases, it can be required to have high definition real-time connectivity with the central location. Another possibility is to just monitor periodically the status of the system, and that would be like IoT use cases requiring very low data rate and frequency of reporting. Smart buoys is a use case where sense data can be collected, for example, on the temperature of the sea, or any kind of sensed data can be collected and exchanged with the central location. In this case, we are talking about IoT use cases. Sea farming, again, kind of information collection over longer period of times with low data rates, typically. And for example, UXVs, Fred also mentioned several times, autonomous ships, for example, or unmanned aerial vehicles, providing supplies to ships offshore, or collecting any samples. So for this kind of operations of unmanned or autonomous vehicles, it would be required to have high data rates, low latency, and high reliability of the connectivities. It can be a proprietary solution, but we'll come later on to a 5G solution as well. So these are examples of North Sea use cases, system requirements or data requirements and latency requirements. And this is just an overview of what I just listed. So for example, maritime radio for voice, for intership or ship-to-coast connectivities, mission critical push-to-talk. Currently, C2000 or Tetra solutions are used for first responders. In case of delay-tolerant low data rate IoT communications for monitoring and sensing data. And then we can talk about high-speed microwave links for data transfer between oil rigs, for example. Legacy satellite communications for video broadcast or multicast, and high-speed, low-latency proprietary links for AR, VR applications, command and control of autonomous systems and unmanned vehicles. But the question is, I've listed a large number of different communication systems that can meet the use cases, the requirements of various use cases on the North Sea. But then I would like to switch to 5G and to see how 5G and whether 5G could be used as a uniform communication technique that can serve all of these or most of these use cases in the similar fashion. So using only one communication technique, 5G, for various use cases. Maybe just going one step back is to illustrate something that you might already know, and that these are the 5G development pillars that were actually specified as the reference points for development of the 5G technology. And there are three pillars. One is enhanced mobile broadband for serving the high data rates, for example, video transfer. Ultra reliable and low latency communications in another corner, and massive machine type of communications. Typically, these are IoT solutions. So 5G was intended to cover all of these diverse use cases, or the combination thereof. And you can see in the middle of the triangle, voice or mission critical applications like vehicular ones, augmented reality that I already listed. So the question is, with which features is 5G architecture characterized? First of all, it is a software-defined networking concept, where it is fully software programmable such to meet specific requirements. It is highly adaptable, scalable, and represent an agile network. So compared to previous generations, there was a combination of specifically developing hardware for specific requirements, but in this case, 5G and 6G will follow in the same fashion. It is fully softwarized to allow fast adaptation of the overall connectivity. There is a concept of network function virtualization where there is no specific function that is implemented in the hardware. Hardware becomes a stupid component of the network, and all the intelligence can be performed on servers, cloud, or edge components. Then I can also say that 5G is fully separating control plane used for control data of the network and user plane for transferring the data. It allows for multi-access edge computing. This approach is very interesting because you can deploy your computing power locally to reduce the latency of the network. And there is a concept of network slicing. Actually, it is provisioning of a virtual network connectivity tailored for specific applications over a physical network. And it is illustrated on the right bottom figure, where actually one physical network can be used to optimally serve different type of users having a wide range of requirements. For example, reliable low latency connectivity can be provisioned for vehicular scenarios, or machine-to-machine communications can be optimized to guarantee a specific kind of quality of service. So these are the basic concepts, and one more that relates to the topic Fred was mentioning several times, and that is the concept of open radio access network introduced in 5G networks. On the top right-hand side, you can see an illustration of radio access network in 4G, and basically a core network, the network intelligence, was connected through a backhaul with radio access network, and radio access network comprises a baseband unit often located at the base station site, and there is a remote radio unit or radio unit illustrated on the top, and between the baseband unit and radio unit very often there was a proprietary interface developed by the vendors. And this kind of vendor oriented solutions were creating the so-called vendor locks that the end users or mobile network operators were locked to come back always to the same kind of to the same equipment vendor, because they were implementing interfaces that were not compatible with other vendors. 5G requires per design, and operators and governments were asking for more flexibility in radio access networks. And the reason, therefore, was to allow for diverse and open ecosystems of vendors. This means that, for example, a radio unit of one vendor could interoperate with baseband unit of another vendor. So actually, it tries to prevent or resolve the vendor lock. New radio access network architectures and solutions are also introduced. Basically, the open 5G RAN disaggregates radio access network into radio units on the right-hand side at the bottom, distributed units in charge of coordinating multiple radio units. And you can see that the distributed unit can be co-located with mobile edge computing server to allow very fast interaction between the radio units. Centralized units are coordinating several distributed units on the larger time scales. And 5G Open RAN and O-RAN Alliance is actually standardizing all the interfaces between centralized units, distributed units, and radio units. And that will allow for a larger vendor ecosystem and equipment vendor ecosystem. Now I will jump to the features of 5G that might be interesting for the North Sea connectivity. And one of the features developed in 5G is the so-called integrated access and backhaul. And it is illustrated on the figure on the at the bottom. So basically, the conventional backhaul, for example, fiber optical backhaul, is connected to a donor node. You can see on the top of the figure on the left top side. And the donor node is actually a base station. And the base station can provide the access link towards the user equipment or the smartphone illustrated in the figure, but using the same communication technique, that is the 5G new radio, it can connect to another base station that is called IAB node in the middle of the figure. So basically, the same 5G radio communication technique is used for to provide access links, but also backhauling connectivity. And you see that on the second base station, again, there is a possibility to use the same communication technique for access link and to extend this backhauling and extend the range of the overall network. This kind of connectivity is very suitable for areas that do not have fixed infrastructure. So, and in that case, you can do the backhauling through multi-hops over the 5G new radio links. It might be of interest in case of North Sea coverage, for example, in case that you that you have the access to a platform or offshore station platform or whichever kind of platform on the North Sea. If you have the conventional, say, fiber to that point, you can further extend and place the next base station and use only the radio access as the backhaul. So in that context, you can extend the network reach in line with requirements. So there is a high flexibility through multi-hopping over the different base stations, and the different frequencies schemes can be used, either the same for access and backhaul or different frequencies for access and backhaul. And at the bottom of the figure, you see that there is a similarity with 5G RAN disaggregation, because we are talking about centralized unit, distributed units, CU, DUs schemes. There are research institutes and universities that have deployed or used Open RAN approach to implement this kind of integrated access and backhaul. So this is one of the schemes that might be interesting for increasing the coverage and connectivity over the North Sea. You can think also about the schemes where these base stations are placed on ships. So it's kind of a dynamic environment where the base stations would move around. Another aspect that could be mentioned is 5G integrate. Oh, okay, it's a wrong title, but it is the Sidelink actually. It is a scheme that provides device-to-device connectivity. And it is illustrated in the figure. In the first figure, we see that the base station talks to a user equipment in the coverage area, and that the UE in the middle is using a sidelink. It is actually device-to-device connectivity to connect or to improve the connectivity towards the users that are on the cell edge. In the second figure in the middle, we can see, for example, a similar case when one UE is in the coverage area of a base station, and it uses the PC5, the so-called link or side link, to provide the connectivity to UEs that are out of coverage. And the last one is the situation where side links are used for direct connectivity between two UEs. And you can think that this might be relevant for first responders if there is no network base station coverage, that they could communicate with one each other directly. I will come later on the drawbacks of or on the weaker side of this side link and integrated access and backhaul. But for the time being, this is the concept that can be used to extend the coverage, for example, around an offshore station, or it can be used to extend the coverage in case of save and rescue or Coast Guard scenarios. In release 19, there is a study ongoing that should study multiple hops over side links. So it might be used to over 2 hops to extend the coverage and connectivity between two UEs. One of the very interesting topics where I'm involved in the standardization process is 5G non-terrestrial networks. And what you can see is on the top figure is the illustration on how up to present satellite was used to provide cellular connectivity. For example, there is a 5G core on a specific location. Then there is a connectivity to a satellite gateway, and there is a legacy satellite backhaul over the satellite. Actually, say DVB-S, for example, is used to transfer the data from the satellite gateway to a remote base station. For example, on an isolated island, there could be a base station, or on a ship. And just from the base station, there is a 5G new radio connectivity towards the end user or the smartphone, for example. What is since 2018 ongoing within the 3GPP standardization is provisioning the so-called direct access connectivity over satellite, and this is illustrated in the middle of this figure. Actually, now we have 5G core, so intelligence of the network, that is connected to a G-Node B on the ground. This G-Node B is sending a 5G new radio signal over the satellite gateway and over the satellite directly to a smartphone or a VSAT terminal, or it can be also an IoT node. So basically, this direct access means that 5G waveform is used all the way from the ground gateway through the transparent satellite to a smartphone, for example. This scheme is standardized in 2022, so 2 years back in release 17. And now the vendors are left the time to implement, and the chip vendors, equipment vendors, and network vendors are left the time to implement 5G non-terrestrial direct connectivity in their equipment. What is currently ongoing in the standardization is introduction of regenerative satellites. These are capable of carrying active components and processing, do complex processing on board satellite. And basically, that would mean that the latency between the end users could be reduced by placing, for example, a base station on board satellite. So in that case, 5G core is talking with the satellite radio interface with a G-Node B or part of a G-Node B onboard satellite. And then from the satellite base station, there is a communication over 5G new radio to the end users. This is currently ongoing in the standardization process. And I would like to introduce the 5G non-terrestrial network performances, expected performances for different use cases or usage scenarios. And I can start with IoT connectivity. That is also one of the relevant use cases in the North Sea connectivity. UE category, that means that there is an IoT device to which the connectivity is established. It is fixed, so it doesn't move, and it provides very low data rates in the downlink and in the uplink 10 kilobits per second. So this is the use case over satellite that can enable sensing and communicating sensed data over satellite. Another one is pedestrian use case, where there is a connectivity to a handheld. In this case, it would be a smartphone, a conventional a power class 3 handheld. And there is a small mobility of the UE, 3 kilometers per hour. And we see that the data rates that can be experienced would be like 2 megabits per second in downlink and 250 kilobits per second in the uplink. Public safety use cases that might be relevant for Coast Guard, or maybe even for specific defense or border protection units, can communicate to handheld or vehicle mounted or ship mounted or boat mounted. It supports speeds of UE or terminal up to 250 kilometers per hour, and it provides 3.5 megabits per second symmetrical in uplink and downlink. So there is now different use cases. We can just go fast through them. Stationary, building mounted, vehicle mounted, and at the end, airplane connectivity. There is a connectivity through satellite to an airplane-mounted terminal that supports 1,000 kilometers per hour and has several hundreds megabits per second in downlink and uplink. So these are the capabilities of non-terrestrial networks. But what is needed, and this is also covered within standardization, are the different implementation practices. And in this case, there are three possible cases. For example, there is one core network, one mobile network operator that is in charge of satellite radio access and terrestrial radio access. And if you are subscribed to that mobile network operator, you can have either terrestrial or satellite coverage. Another approach is that there are two core networks, one serving terrestrial network and the other one serving satellite radio access, where there should be agreements, roaming agreements between two operators in order to provide seamless connectivity between terrestrial and satellite. And then there is a shared non-terrestrial network access where there is one radio satellite access that is connected to different cores. We will see that this middle one could be, for example, a relevant, okay, all of them are relevant for North Sea connectivity, but the middle one is a typical combination of terrestrial networks covering the coastal areas up to specific distance and satellite access networks that would cover longer distances on open seas. I will illustrate now. I can recommend for a nice reading. There is a project, European project 6G NTN, that is analyzing how non-terrestrial networks will be used in 6G networks. And one of the use cases is the save and rescue team connectivity on sea. And the first use case that is illustrated there is the connectivity at sea using terrestrial network. I think that Fred already illustrated this kind of connectivity where the remote Coast Guard headquarters uses 6G or 5G core network that is connected to a base station on the coast. And then in case lower frequencies are used, the reach of such base station can be several tens of kilometers off the coast. So this is illustrated with this use case, and this is purely based on using solely coastal base stations to provide connectivity in the coastal area of the sea. Another very interesting use case is connectivity at sea using terrestrial networks and non-terrestrial networks. So now we see that this save and rescue team moved a little bit further off the shore towards the open sea, together with helicopter and drones. And we can see that this SAR team is out of coverage of the terrestrial network on the coast. And for example, for whichever reasons, if there is a feeder link unavailability, remote Coast Guard headquarters will not be able to establish direct connectivity to the rescue team. But what is currently analyzed within release 19 of 3GPP non-terrestrial networks is how local satellites could be used to provide UE. It's called UE satellite UE connectivity. So user equipment of a helicopter can talk via satellite to the user equipment on the ship in danger. So this is one of the interesting use cases where local users either can establish a direct connectivity through side links, or they could establish connectivity through satellite if the distances are a bit larger. And finally, another use case is a combination of both coast base stations or coastal terrestrial networks and non-terrestrial networks that can both terrestrial and non-terrestrial could establish connectivity with the core network on the ground. So we can see that resources of terrestrial networks from the coastal base station towards the SAR team could be combined with connectivity, 5G non-terrestrial network connectivity over satellite. And this is something that might be very relevant in case of North Sea coverage. There was a question on what is the reach and what kind of services could be provided on which distances. As an example, I can refer to some trials conducted by China Telecom and Huawei, and it is summarized in GSMA publication 5G promises to transform marine industries as a source. And here is illustrated how this combination of coastal base station and satellite could be combined to provide connectivity over different distances of the coast. And we can see here that they are talking about high towers, so highly positioned base stations using 700 megahertz and 2.6 gigahertz. And with such frequencies, they can provide video or web surfing up to 10 kilometers using coastal connectivity. They say offshore connectivity up to 30 kilometers with lower data rates, I would say, so reduced data rates, and at open seas up to 50 kilometers they claim to have connectivity, but with very limited data rate. So they provide connectivity with low data rates. Everything beyond that, they propose to use high throughput satellites, possibly in combination with 5G NTN. So this is a nice illustration on which kind of services and which are the trials already conducted in similar scenarios as we can expect in the North Sea. So I think this brings me close to the end, and I can summarize the presentation that 5G is actually a promising technology to enable connectivity over the North Sea by using different features to serve different type of North Sea user types. There is an advantage that 5G can provide integration of terrestrial and non-terrestrial solutions in order to increase reliability, in order to increase the reach of the network. Cost-efficient network deployment through economies of scales, because chips, components, equipment, and network products are developed and fabricated on larger scale. the costs of implementation or devices reduces compared to proprietary solutions. It offers diversity of the ecosystem through, for example, Open RAN, that different radio access network vendors could combine, or products of different RAN vendors could be combined. And it allows for software-based flexibility and scalability, that all the changes in requirements could be adapted in the network such that the network best optimally meet the requirement. And this software-based approach actually is the smooth transition, allows for smooth transition towards 6G. The challenges still to be solved is the point that commercially not all 5G features are available. There is a discrepancy sometimes between a 5G standardized feature and the availability of that feature in commercial equipment. And in this case, I can refer to this feature of integrated access and backhaul that has been standardized already several releases ago, but it is not yet commercially available. There are some all-run implementation of research institutes, but that is not on a larger scale. Also for this side-link implementation, it just started being implemented for vehicular-to-vehicular use cases. So sometimes the 5G features that are standardized need to be or are implemented with a time delay because of the request from the market. If the request is too low, the implementation might not occur. So that is one of the challenges that needs to be taken into account. I can say that for the 5G non-terrestrial networks, there are no commercial services yet, but there is a vast number of trials that are either pre-3GPP based or are aiming to have 3GPP implementations. And they're starting with IoT messaging and applications, and then it is expected that data or higher data rates transmissions would be somewhere in the future. So it is a stepwise approach that is currently ongoing numerous trials for 5G non-terrestrial network implementations. But it is expected that like in the next year, there will be first 5G non-terrestrial network IoT commercial services available. Frequency allocation and frequency sharing. So that is also a question on how this national jurisdiction of frequency allocation can be combined with international frequency allocation on high seas or on open seas. That is relevant in this North Sea use case. So that would actually conclude my presentation. So I don't know whether I was, whether the timing was good. So any questions?
Yeah, no, it was good. Relja, fantastic. There are some questions or some topics that were discussed in the chat. And one was, and it's also a topic where Fred could maybe say something. Who would be operating such a 5G, 6G network? It wouldn't be a classical Vodafone or Dido or something that sells SIM cards. It has to be something different. And they have to place their equipment on locations that belong to particular companies and authorities, etc. So what are the views there?
Maybe just I can get back to this figure. So basically, there are different deployment integrations scenarios, and for example, what is there is 5G America's paper on ongoing trials. What is happening is usually that a satellite operator combines the efforts with terrestrial mobile network operator. And there is, I think T-Mobile combines with Starlink. I would need to check, but this kind of joint efforts of a terrestrial mobile network operator and a satellite operator are very often in the trial phase of this.
And in this kind of network, who are the clients? What do they use it for?
For example,
not you. Yeah.
For example, it would be like roaming between TN and NTN. What we can think of in the US, they have several trials where there are regions that do not have terrestrial network coverage. And in those cases, any user that finds himself in the region without terrestrial coverage would be served through his mobile network operator agreement with a satellite operator with conventional mobile network services. So that is one example.
Yeah, but the users there would be consumers, actually.
Consumers. It can be anyone that has,
Fred, maybe you have to add something to that. How do you see that?
Well, yes, the scenarios Relja is showing with non-terrestrial network integration is, of course, very specific. I think it will be very interesting for the North Sea for offshore deployment. But as we see it, as Rijkswaterstaat and together with TenneT, we have the installation points, the masts, and I think that a system integrator, typically more like the industrial system integrators that are doing it indoors, but also outdoors, will be can play a role. I don't think that the government or a governmental organization like Rijkswaterstaat should become a telecom operator. Of course not. But if they own their own spectrum and they also can hire the maritime service providers for maintenance of the physical maintenance and stuff, then I think there will be a new generation of connectivity service providers also on land that can play a role. And I think that the classical operator that has both the masts and is operating the core network that's not that situation will be gone anyhow, I think, because the core will be deployed in cloud in hyperscale data centers for the mass consumer, but also on premises or in private cloud networks they can be deployed, and they have another kind of service integrators, I think, that can help out an organization that just provides the neutral host, so to say, on sea. But I don't think, if there are already examples of it, I don't know.
You would like to add something, Relja, to that? No. Okay. All right. And
Ignas, you are muted.
Yeah. There was another topic on more technical on integrated access and backhaul. And the question is, does this go at the expense of capacity for the UEs the fact that they use part of it for the backhaul, or they use different frequencies, or beamforming, etc. So, Relja, what's your comment on
yes,
that?
indeed, there are two different flavors of the integrated access and backhaul, and one is the so-called in-band. So the same frequency is used for access link and for the backhauling. And indeed, in case you have the more hops you have, actually the more price you would pay for the access link data rate, because you are actually sharing resources between backhauling and access links.
Yes.
In case of using different frequencies, that might be somehow simplified, but still you need like slots for exchange of data between the backhauling and access links. So there is always a price you would pay in reduced capacity, but it is a very useful tool or feature in extending the network reach. And as you mentioned, using beamforming might also be a useful approach to limit the losses in the provision, the data in the access link.
Okay, I think we should finish here our webinar. I would like to thank both speakers very much for very interesting talks, and also the audience for let's say for the discussion in the chat, among other things. And normally we should give an applause. That's possible with Teams. What is not possible with Teams is that usually when we have a physical meeting in The Hague, we tend to give to the speakers a little attention, as you can imagine what kind of thing that could be. So there is no such function in Teams. So you will have to watch your email for that. So again, big thanks to all of you, to the audience, and yeah. I would also encourage everybody to become a KIVI, that is not a KIVI member, to become a KIVI member. So that's easy. Okay, so I wish you all a very nice evening, and thanks again. Bye-bye.
Bye, everybody.